Hello guys, you are welcome here in my YouTube channel. Today we are here to solve problem lead code problem of the day, and today is 13th November 2024. Let's begin with reading the problem statement first. And the problem statement is most beautiful item for each query. If you will read the problem statement, you are given a 2D integer array items where items I equal price I and beauty I denote the price and beauty of an item respectively. You are given a zero index integer array query, and for each query j you want to determine the maximum beauty of an item whose price is less than or equal to. You have to take care that whose price is less than or equal to query j. If no such item exists, then the answer to this query is 0, and you have to return an array which will be the size of length or length of queries array. So this is all about the problem statement. If you will read it carefully, you will see that there's the item given here. In the example, you can see that these are the item that is given here, and these are the query. So what the actual problem is, the first index denoting the price and the second index denoting the beauty. So let's say that if the query is given 1, so you will have to check all the prices that will be less than or equal to 1. So corresponding to the values, you have to maximize the beauty. So for this one, if you will set that how many prices are available which is equal to or less than 1, so you can say 1, this is the eligible candidate, and no one's. So there is only one pair, so in this case the answer would be 2. Again, let's start with the second query is 2, so you have to check less than or equal to 2. In this case, this will be the eligible candidate, and because the price is 3, so we will not consider this pair, and because this is the 2 and your query is 2, so we will also consider it. And then so from this one and these two, from these two you have to find the maximum 2 and 4. The maximum 2 and 4 will be 4, and again the query is 3. Query is 3 for 3, these are already 4, so you have to just check 3, then 3, this is the eligible candidate, these are not the eligible candidate, and this is the eligible candidate. So maximum either it could be the 4 or maybe, so maximum will be out of 2, 2, 4 and 5. So maximum will be 5, so that's why the answer is 5. Similarly, see for 4, if you will check for 4, 1, this is also eligible pair, eligible pair, eligible pair, and these are not eligible pair, so these. So among these, if you will skip this pair, all other pairs have the maximum of beauty 5, 5, and this 2 and this 2 and this 4. Out of these one, 5 is the maximum, so that's why answer is 5. So the next query is 5 less than or equal to, you have to find a maximum beauty for the price that will be less than or equal to 5. So in this case you can see that all the candidates that are available here, these are the first candidate and these are the second candidate, all candidates are eligible because the query price is 5. So out of 2, 2, 4, 6, 5, the maximum is 6, that's why the output is 6. Similarly for 6, because less than or equal to 6, so exact 6 is not available. So sorry, for this 6, exact 6 is not available, price is not available, but you have to find less than or equal to, whose price is less than or equal to. You can see that whose price is less than or equal to Joe. So that's why you have to find it, uh, maximum out of all pairs, beauty out of all pairs. So 2 2 again the 6, so that's why the output is 6. So this is the explanation that how the given input giving the correct output. Similarly, if you will see the second example, you can see that all have exactly one price, and that is one. So the query is one, so you will just have to find the maximum of beauty among all these pairs. So 2 2 3 and 4, so 4 is maximum, so that's why the answer is 4. And for the 3, you can see that 10 and 1000 is given, but the query is 5. So less than 5 there is no price available, so that's why the answer is 0. Here also in the problem statement it is mentioned that if no such item exists, then the answer to this query is 0. So that's why the output is 0. Let's start. What is the constraint about this problem is query length and items dot length, the number of pairs, I mean the number of pairs, and the number of query would be from 1 to 10 to the power 5, and each items have length 2, price and beauty. And for this you can also see that the values that will be the values of price, beauty or query of j belongs from in the range of 1 to 10 to the power 9. So this is all about the problem statement. So let's start that how we will approach the problem and how we will bring a solution and what will be our the thought process. So let's start. Okay, all right. uh, no, let's try to copy an input so that we can understand it better. So these are the items and that are the queries. So at the beginning when I see the problem, I was just thinking that how we can approach. So I was thinking that maybe because it is not dependent on the indexing, you can check like index of 1 is this 2 and index is 2 and the index of this one is 3. So I thought that index is not doesn't matter 3 and index of this one is 4. So why we do not think about to sort the array? So I was thinking that okay, if I will sort this array, so uh, if I will sort this array, because I was just you know trying to implement binary search somehow, because it was given that if your query is 5, all the element that is less than or equal to 5, you will have to traverse in each of the right left hand side, and you will discard all that are all the pair that are available in the right hand side. So that's why I was thinking to implement binary search somehow, but there was an issue. I will explain it later. Like if you will sort it 1 and 2, okay, then again 2 and 4, and then again this will be the 5 3. So if the first element will be equal, so it will be sorted based on the element that is on. So where we go, okay, we were explaining that how, so we can discard the left right and right part of the items array, and you will have to consider all that are available here in the left hand side. There is one more edge case that are given here. You can say that if you are given a query which is not available in the array, so in this case, like this one, because the price has started from 10 but your query is 5, so there is no element in the items array, so you can not find anything. In this case you have to return 0. So okay, 3 and 2, and less. I was thinking to sort on the basis of the first element, but if the first element is equal, so on the basis of two element, I will, on the basis of second element, I was just trying to sort in ascending order, non decreasing order. I mean, so 3 and 2, and next one is 3 and 5, and the next element is 2 4 is there, okay, and then last one is 5 and 6. So this will be the, the array after the sorting. But I was thinking that okay, if it is sorted, if I will apply banish, if I will apply banish search on this array, so I was thinking that how I will get the answer. So I was just thinking that okay, if the query is 1, so I will go in the middle and see the price. So I see that price is 3. So what I have to do, I have to, because the query is 1 and this is available 3, so you have to go left hand side. So on here 0 1 2 3, and this one is 4. And here then the r l will be here 0, and here it will be the r, and it will be the mid. So r will go to here, so from l to r, so we will find the mid. Okay, my mid will be here, so in this case mid will move to here. So we will check that the price is 1 and the query is 1, so this is the eligible candidate, so the answer might be 2. So the 2 answer will be there, okay. Similarly for the next 2, for the next element 2, I was just thinking that okay, for 2, similarly we will again find the binary set. 3 is not there, so okay, it will go to 1. 1 is the eligible candidate less than or equal to, so in this case we will just make it eligible candidate, so 2 would be the answer. Maximum of 2, and because this was the eligible and the further element can be the eligible, so we cannot break here. We will move the L to here, L will move to here, and R will remain here. Oh, sorry, R will here. So L and R will both point to this index, so 2 is equal to 2, so in this case we will also consider 4, so the maximum will be 4. So in this way I was just thinking that my approach will give the correct output, but there is a problem in this approach. I was just think like let me explain you that what will be the problem. If the similar example, if there is the like something, um, let's say, I mean something like how to explain it, something like that, mm, there is the pair something like 2 3 and then fourth pair, and similarly many pair are here. So let's suppose that mid is here. You find a mid is here, you find a mid, and let's suppose here is the k, and k plus 3 is the query. So k might go here, but here let's suppose it is given that 6, and here it is given 10, and here it is given 20. So because you know that k, all the left element is eligible, but if you will simply apply the binary search, it will say that okay, this pair is the eligible candidate, so we should move rightward. But this is the wrong approach. Why? Because you know that these are the maximum, these are the maximum 10 and 20. If you will consider 6 and further element, let's suppose that this is the k plus 4, k plus 4, and let's suppose 2 is here, so only the 6. In general binary approach, it will be considered as okay, the 6 I have found, and so the answer output will be 6. But this is the wrong output, because the answer is maximum of 20, 10 and 6, so answer is 20. So what we, so that's how I, you know, change my approach. So I was just thinking okay, if I have to iterate all the element that is available to the left of this element. So again then I was thinking that is there any way we can implement segment tree. So I was just thinking, is the segment tree will help me here. So I was just thinking that okay, if I will, let's suppose it will be my array from 0 to n, and if I will break out 0 to n by 2, and n by 2 plus 1 to, let's suppose, n. So if there will be the query, I have to iterate all the element that is available from 0 to an eligible candidate that is available to an index such as k. So I have to iterate all the elements that are available in this range. So when you know segment tree will not exactly help me out, so that's why I also drop this approach. So then I was thinking okay, this will not, but what if we will try to make an approach something like prefix sum, because it will help me out, because if let's suppose here something like prefix max, like very similar with the prefix sum. Prefix max, if we will find the prefix max, like okay, I will, if I find 1 and 2, and for this one 2 and the maximum on 2 and 4, this will be the 4. Okay, and then and next one is 3 and maximum of 2, 4 and 2, the maximum will be 4. Okay, the next one is 3, a maximum of 5, 2, 4 and 2, so it will be the 5. Okay, then again 5 and the maximum of all and including the 6, that will be 6. So this approach will help me out. So you can see that if there is any query that less than or equal to 0, so in this case now I will be able to apply the binary search, because let's index is 0, 1, 2, 3, 4. In this case, if the mid will hit to here, mid will be here. So okay, if mid will be here, this will be the eligible candidate. If let's suppose the query is 3, so 3, okay, 3 hit the 3, okay, it's okay. So I will move the left pointer to the next, and R will be here. Okay, R, and then from left at the beginning L will be here, so then L will be here and mid goes from here. So L and R will be here, so mid will be something like this. So it will point to mid will goes to here. Okay, so because it was a 3 and potential, there will be an answer will be 4 from this pair. So L will goes to here, find, I will find the mid, and mid will be here. So in this case 5 will also be a eligible candidate. So again we will find the mid. Okay, I will move the left to mid plus 1, so this will be the L, because L are and same, but 5 is greater than 3, so we will break the loop. So among these two, the maximum will be our answer, so the answer will be 5. So this approach will work very efficiently and very perfectly. So that's how I approach the problem, and let's begin to code it now. Okay, so at the very beginning, let's try to find length items. Okay, so as I said that you have to sort it to apply the binary search. So I will use the lambda function b compare the basis of b 0. Okay, this is how I sort. So in the similar way of prefixum, we will find the prefix max. So items of, because 0 will already be in the map, so we will not update. So the maximum of, so this will generate the, this array that I was talking about. It will generate I mean it will sort the array some in the ascending order, and then it will generate the array something like this. So again, now let's start with the query. If for query start now, you have to check, or something like this example, you have to check that if queries dot I is less than items of 0 0. If that is less than 0.0, in this case you have to, for the answer I will update the query query array. I will not make any extra array. I will do update the answer in this query array. So what I will do is, else you have to do the binary search. So let's suppose there will be a temporary answer that will be 0. So int will be l from 0, int will be n minus 1. So mid will be, okay, if have to check it something like this. So I will copy this. Okay, if query of I is greater than or equal to, this will be the I. No, it will be the mid. Okay, it means that that the query is given and the price of the current item is less than or equal to the query. So this will be the a potential answer. So that's why we will consider it. Answer will be math dot maximum of answer comma and that will be 1, and we will update that l equal to mid plus 1, else r equal mid minus 1. That is not the available, so you will have to go left. So return, mm, I'm returning the query array because the query array, I am just modifying the query array. I'm not make generating any, and I'm not taking any extra spaces. So that's why I'm using that are the array that are available. So I think that's it. Let's try to run the code. If there will be something error, we will check it out. So why is what this happening? It's saying that 1 2, the output is 1. Okay, never the answer because there is no one available here. So I item, oh sorry, this will be the one. This will be the one item that are available on I minus 1, and this will be the one. Sorry. Okay, now what's happening? Let's see. Again one. How this? This is okay. And this will also be the okay. And the answer is not need not to make it the maximum. How it can give answer one? It's not possible. Let's see it again. Same problem. Let's see. Output should be two. Query of y is less than items of. Is it working fine? Yeah. Okay. Mm, or will be from here. Let's see. Oh, sorry. This sorry. The query is okay. Items on maiden. Okay, query is not updating actually. That's why. What the answer is. Okay. We are not updating the query. That's why here there is the error that we are not updating it. Okay. After that, you have to update that query of I would be equal to the answer. That's why the output was wrong. So you can see that the test cases that are available here have been passed. So let's try to submit the code now. So you can see that our code have been accepted, and I have written the code in Java. So you can see the runtime, and that is a 44 millisecond, beats 82.61% of the people that have been submitted in Java. So let's try to analysis the time complexity. We will not see here where till we will analyze the time complexity. So these are the sorting. So sorting is n log n, and here it is the linear time complexity, and here again the linear, and here it is the log n. So log n and n, this is the length of query, and this is the log of length of. So let's try to see the time complexity will be order of n log n for sorting, plus order of n, because we are making the prefix max, something like that, and plus then this will be the, if the query of length of query is n, so log of, if the length of items is n, so this is the n. So this is all about the time complexity, so you can roughly say that the time complexity is n log n. So let's try to see the time complexity here. You can see that n plus n log n. So this is the time complexity. So this is all about the today's problem. If you have any query or suggestion, you can ping me below in the comment box. Whenever I will get the time, I will definitely respond and reply to your query. Stay healthy and keep growing. And if you feel that my videos is helpful for you in coding and CP, so you can share with your friends. Please make sure to like my videos and please comment below. And please also subscribe my channel. Thank you.